Yes, hello. I'm Charles. Today I've got this laptop here. It's an HP EliteBook 840. It's a G1 and it's doing something that is very common. When you plug in the charger, it does not display. However, it turns on and the fan runs very fast and then stops and then starts again. When you look at these indicators, can you hear the fan? Then it does that and goes off. The power button also keeps on coming on then off, plus these lights. Can you see that? So this issue is very common in this laptop and it looks to be simple, but it's not simple. So this one I got it from some guy and he had taken it to some technician. They tried to change the CPU control chip because when you don't see voltage on the CPU, you would probably think it's the control chip that does this, but it's different. So let me show you how you can diagnose this. Now, in such a condition, the first thing you have to do is to check for the standby volts, and hereby we check for this one. 5 is present, 3.3 is present, RAM voltage is present, charging voltage is present because the battery is not in. Then when you check here, this has to be giving out 1.5 for the CPU, is also present. When you check here, this is meant to have 1.05 for the chipset, but it's giving out 0.2. Can you see this? So this usually indicates that the chipset cannot proceed because there is no this kind of voltage. The laptop tries to turn on, but because it cannot get the feedback that this power is fine, that's why it goes on, then off, and then tries again, and then off. So when we check the CPU power, it is 0. It cannot come on until the chipset is on, because the chipset is the one that controls this chip that turns on the processor voltage. So what I'm going to do, disconnect this jumper. So after I've disconnected the jumper, we are going to check to see if there is a short, because usually a short can drop that voltage. So when you check here, resistance 65. 65 is not bad for the chipset. When you check ahead, 169. This is not bad. Then we are going to power it on to put the adapter when the jumper is disconnected to see if you can get the voltage. So when I disconnect the jumper, we get 0 volts. This means this chip that is meant to produce or to create the chipset power is not either working or is faulty, or the signal that turns on the chip not present. In laptop, there is what we call power sequence. So power sequence is the step-by-step that shows which voltage comes first and then which comes next. So the power sequence of this 840, as I'm going to show you in the schematics, it shows that these volts come first, then after these ones come, RAM voltage come next, then after this comes. So processor voltage cannot come until chipset power is up. So what we are going to do now, we are going to check this chip that creates the chipset power. Now when you look at the way it looks, it seems to have a damage here at this side. Can you see this damage? After seeing that this chip is not producing the chipset power, can you conclude that the chip is faulty? We cannot just conclude. I'm going to show you how you can diagnose and test this chip. So let's head straight to the schematics. So this one, the chip is called U6300. So I've got here schematics for this motherboard. If you don't know how to get schematics for laptops, I've done videos about this. You can check my channel for such videos. And here I have these schematics for 840. We are going to check for this chip. It is U6300. So this is the chip. So when you look here, this chip has got 28 pins plus the ground, which is the bottom. Pin 1 is called peak good. Peak good stands for power good. So this is the signal that it goes to the, actually communicates to the EC that this chipset power is good. That's pin 1. Then you have V in, which is connected to PV bat. This is the voltage that comes into the chip. We have V5. We have 5 volts comes into the chip. And then we have this pin, which is 28. This number 28 is very useful and it's actually one of the signals that we have to focus most on, because this pin 28 shows that enable, which is EN, enable 105 volts. So we are going to measure and see, are these voltage available? So from this dot, that shows that is pin 1. From the schematics, pin 1 is called peak good. So let's check for pin 1. So pin 1 has 0.6 volts. So pin 1, remember, is the one that communicates to the EC to show that this power is fine. So pin 1 is automatically absent because the chip is not working. Then let's go to pin 15, 16 and 17, which is V in. So that's where the power that turns on the chip comes in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 15, 16, 17 is connected to this capacitor. And when we check here, we see that 19 volts is available. So V in is available. And actually you see they are all joined together as the schematic shows. When you see here, they are all joined together. Okay. So let's look for pin 18, which shows that is 5 volts. You see for 5 volts is available. So pin 18 and it's connected to this capacitor. So you can see that 5 volts is available. So let's measure for pin 28, because if we have V in, we have 5 volts, then we need to check, is the chip, is it commanded to turn on or not? So let's check for pin 28. 28 is this last pin, this one. So let's check and see if the chip is commanded to turn on. You can see there is 3.3 volts that commands the chip to turn on. But when we check, you can see that there is no output. So the chip itself is not shorted, but it's faulty. Alright, so let's proceed to replace this chip. I've set my blower at 340 degrees and the air is at maximum. So the chip is out. I'm going to apply this long weight solder so that when I'm replacing the other one, the board will not take too much heat. So I've got here another motherboard. So this one, I'm going to use it as a donor board to extract this chip and replace it here. Okay, so it is out. So you have to identify this number. Can you see this one is TPS 51362? When we check in the schematics, it is called TPS 51362. So let's inspect these terminals under microscope. This one and this one. This side, they also well soldered on. Then when you check here, so after inspection, let's measure for short. Yeah, it's not short. And then in the input, still not short. Measure for 5 volts. Not short. Okay, so let's put back and test. So you can see now we have 105 volts. Okay, can turn on. So let's put back in the frame, then we can test. So let's put in the adapter and we see. Fan spin. But still not display. Now we have replaced these chips, but still the laptop is not giving out the necessary voltage to display. Now what we are going to do, we are going to check for power good signals. Here in schematics we have this chip which is called U7400. Now U7400 at pin 7, it gives out a signal called power good 3. So power good 3 is a collection of most of the signals that first boot up before we proceed to processor power and PCI power. So here it shows that this is an operation amp. As you can see, if you know some information about operation amps. Okay, this is a comparator. It compares the input from the reference. Now this is a collection of all the power good signals. Now we have 5 volts VS. It comes up to here, goes to pin 5. We have VRP VDD tune. This is power good for RAM. We have M power. This one is for chipset. We have sleep 3. This is a turn on signal. Then we have the same chip on pin 3 is where the reference is connected. That's why you see that 3.3 volts reference. That's why you see it as ref. Now this on pin 3, actually we have on pin 3 we have 1.05 S. This is the chip we replaced, the first one for the chipset. So it has to send a power good signal here. Then we have G power good. These are graphics power good. Then we have 3.3 S, and then we have 1.5 S. PG. PG means power good. So all these signals come up to pin 3 and pin 5, so that this chip can give out power good 3, which means the first section of power signals are all fine. So this signal goes to the EC, this one. Then this one sends to the chipset, and then the chipset proceeds to turn on the processor voltage. So we're going to first check the state of this chip. So the chip is here. I don't know if you can see it clear. So when I measure, remember in the schematics it says pin 8 here is V plus, which means it's the power that turns on this chip. So we are going to check on pin 8 first to see if we have VCC. So this is pin 1, 2, 3, 4, 5, 6, 7, 8. So here at pin 8, yes, VCC we have, that is 5 volts. Then we check for pin 7, which is attached to pin 1 through this line, to see if we have the output. So pin 7, since it's attached to pin 1, let's measure from pin 1, and we are having no output. So let's check on pin 3. Pin 3 we are having 1.2. Let's check for the reference, which is pin number 2. And reference we have 0.6 volts. So let's measure pin 5. We have the reference, pin 6, and we have 0.6. At pin 7 we have nothing. That's not normal. So this chip should be able to give out the good signals, but still it's not giving out. So let's change this chip before we go any further. So it is out. So you see this terminal was broken. So this probably could have been the reason why. So it means the 5 volts could have come very strong and shot out to this pin, so that it actually broke from inside. So let's replace with another one. So I have got this. I've taken it out from this donor board and put it in position. Let's plug in. And let's measure. When I measure on pin 1, we have 3.3. Remember, it wasn't giving out anything. Now when I measure here, you see that we have 1.7. When I measure here, we have 1.5. So let me put it into the frame when then we test the display. So let's test. Let me plug in. Ooh, can you see this? The laptop is now turning on. The fan is running. So I'm going to put the heat sink, assemble it back, and give it to the customer. Otherwise, thanks for watching. And don't forget to subscribe. I will see you in the next one.